Welcome to today's Explainer. Whether you're writing code every single day or managing the folks who do, having a solid grasp on logic is absolutely everything. Today, we're going on a rapid-fire journey to build your ultimate programmer's toolkit. We'll be looking at the fundamental building blocks of decision-making, memory storage, and automation. So, let's get straight into it.
Okay, let's dive into this. Have you ever wondered how a game actually knows when it's game over? Well, it's not magic. It is just conditional logic executing at something like 60 frames per second. Just like a game constantly checking if a player's health has hit zero, every single intelligent program uses conditions to make decisions and trigger immediate, precise responses.
To make sure we're totally covered, here is a clear roadmap of the toolkit we'll be building together today. First, we'll look at the power of decisions. Then, storing data in arrays. After that, we'll talk about automating with loops. And finally, we'll wrap up with a quick survival guide on avoiding common coding mistakes.
Section 1. The Power of Decisions, the Engine of Real-World Logic.
Think about what a program would be without decision-making logic. It would just blindly do the exact same thing every single time you ran it. To fix that, we use the if-else statement. Think about a basic traffic intersection. If the light is green, cars can go. Else, if the light is yellow, slow down. Else, stop. Standard if-else logic is just incredibly elegant because it perfectly mirrors human decision-making right into machine execution.
Now, when decisions get a bit more complicated, we combine multiple conditions using logical operators. They act like strict rules. The AND operator is incredibly strict. Literally, both sides of the equation must be true. The OR operator, a bit more relaxed. It only needs one side to be true. And the NOT operator simply flips a true to a false, reversing the logic instantly.
But here's the secret. If-else isn't the only way to route your logic. When you're dealing with massive lists of fixed possibilities, switch statements are a total game changer. Instead of checking conditions one by one, a switch uses a blazing fast jump table to inspect fixed data values. It is so much cleaner and noticeably faster when you're checking a single variable against many fixed outcomes.
Which brings us to Section 2, Storing Data in Arrays, the lockers of programming.
So, what happens when we have way too much data for single variables? That's when we use arrays. And this brilliantly illustrates the concept. Imagine a long row of school lockers. An array is simply an indexed list of values, grouped under one variable name. The one strict rule: every locker holds exactly one type of item, and all items must be of the exact same data type. You definitely can't mix strings and integers in there.
Conceptually, if we peek under the hood at how memory actually works, it allocates a continuous block of space for these structures. You can literally just see these perfectly lined up, empty boxes in memory, just waiting to be filled sequentially with a huge list of student grades, grocery items, whatever you need. Now, to actually find an item in those boxes, we use an index number. And pay attention, because this is a crucial detail that trips up almost everyone. Arrays almost always start counting at 0, not 1. Position 0 is always your very first item.
However, I do need to highlight a fundamental limitation here. Because arrays use that strict, continuous memory allocation we just looked at, their size is completely fixed the moment they are created. You can't just stretch them out. If you need more space later, you actually have to endure the cost of creating a brand new, bigger array and copying all your old data over.
Section 3. Automating with loops, processing lists efficiently. Okay, so we've stored all this data in our array lockers, but how on earth do we process it all without writing hundreds of lines of code? Loop operators. They automate repetitive tasks, allowing you to loop through a block of code effortlessly, like checking every single book in a digital library. They are the ultimate time saver for scanning a massive array to find one specific item.
And when it comes to loops, the for loop is the undisputed workhorse. It's incredibly powerful because it gives us absolute, complete control over exactly how many times a block of code will run. This makes it a match made in heaven for arrays, because we usually know the exact length of the data we're dealing with.
So the crucial point is that a for loop requires 3 mandatory phases to function correctly. First, initialization, setting your starting point, usually at index 0. Second, the condition, telling the loop exactly when it needs to stop. And third, the update, moving your counter to the next item after every single pass.
But hey, we don't always have to sit around and let the loop run its full course. We can use branching statements. If you find your target data early, you can use the break command to terminate the loop entirely. Or if you just want to skip over one specific item, the continue command skips the current iteration and leaps straight to the next one. Very handy.
Let's bring this toolkit together in Section 4, Avoiding Common Coding Mistakes. Consider this your survival guide.
Let's do a rapid-fire review of traps that even experienced programmers fall into. First up, good programming style. Readability isn't just a bonus, it's essential. Use meaningful variable names. Write out temperature, don't just use the letter T. Enforce consistent indentation. Use blank lines for readability. And never duplicate tests in your if-else logic. Good style makes code readable for both you and your team. Next, I want you to memorize this simple mental checklist before you access any array. 1. Is the array null or empty? 2. Is the index actually in bounds? And 3. Are you accidentally modifying the array's size while iterating? Failing to perform these simple checks is literally the root cause of countless bugs and runtime crashes.
Which leads us directly to the undisputed king of bugs, the off-by-one error. It is the most frequent array mistake across all programming languages. Remember how easy it is to forget zero indexing? If you have a 5-item array, its highest index is actually 4. It's so incredibly easy to accidentally try to access index 5, and boom, your entire program comes to a screeching halt.
To wrap up today's explainer, I'm going to leave you with a final, provocative puzzle to test those newly acquired skills. Based on everything we just covered about zero-based indices and loops, can you spot the bug hiding right here in this for loop? I'll give you a hint. Keep a very close eye on that less than or equal to sign. Thanks so much for learning with me today, and keep sharpening that toolkit.